everybody, thank you for watching. This is our 9.2 video about boiling versus evaporation. In this video, we're going to talk about vaporization of liquids using our kinetic theory and then describe on a molecular level what happens to a liquid when it reaches its boiling point. Lastly, we're going to talk about the process of sublimation. Let's first start by talking about the different phase changes and how many we think they are. So we know that going to a solid to a liquid to a gas, that's considered a phase change. But if you count in both directions, you actually have 6 total phase changes. In gases and liquids, going from a liquid to a gas, that's called vaporization. Going the opposite direction, gas to a liquid, that's called condensation. Liquids and solid, we know that's melting. Going from a liquid back into a solid, that's freezing. These two that you might not be so familiar with, going from a solid straight to a gas, that's called sublimation. And then going from a gas into a solid, that's called deposition. So what we're going to focus on in this video is particularly vaporization, and that's going from a liquid to a gas. So there's 2 ways vaporization can occur. We can evaporate, which is also liquid to a gas, or boiling, which is also liquid to a gas. So what are their differences? Evaporation occurs very slowly, and it depends on the temperature. When you're evaporating, you're heating something, and only the particles at the surface are going to escape outwards into a gas. The difference is when you're actually boiling something. Boiling occurs very quickly. And when that happens, all the particles, not just the ones at the surface, have enough kinetic energy to become a gas and escape into the atmosphere. Now that you know the 2 ways vaporization can occur, let's talk about boiling a little bit deeper. So let's pretend we have a beaker of room temperature water and we want to heat it. Room temperature is at 20 degrees Celsius, and we know that water boils at 100 degrees Celsius. We're going to take this beaker over here and we're going to heat it up to 65 degrees Celsius. When that happens, we want to evaporate, and what's happening at the evaporation is some of the particles at the surface are going to escape into the air. When that happens, you have some sort of pressure pushing upwards at the surface of this beaker. That pressure is called vapor pressure. So let's pretend our vapor pressure right now is 0.5 atm. We also have pressure that's pushing downwards this way. That pressure is called atmospheric pressure. At sea level, that's where we live, atmospheric pressure is 1 atm, and that's kind of just a standard at sea level. So we have pressure being pushed this way, and we have pressure being pushed this way. Let's say we increase the heat a little bit to this beaker, and now we're heating the water up to 85 degrees Celsius. What we're going to see is we're going to see more particles are going to escape into the air, more vapor pressure is going to increase, let's say maybe 0.8 atm. Our atmospheric pressure is going to stay the same because we're still at sea level. Lastly, the difference is when we're boiling. We know water boils at 100 degrees Celsius. So what's happening is when we're boiling, our atmospheric pressure and our vapor pressure are equal to one each other. And that's the only time boiling occurs. So the amount of pressure being pushed this way is going to equal the amount of pressure being pushed that way. So therefore, our vapor pressure and atmospheric pressure are the same. And at sea level, our atmospheric pressure is 1 atm. So quick summary, you are not boiling until your vapor pressure and atmospheric pressure are equal to one another. And that's kind of the key point between the difference between evaporation and boiling. Now that we talked about boiling, let's come up with a definition. So our boiling point is the temperature when a liquid vapor pressure equals the atmospheric pressure. And we also have something called normal boiling point. And the normal boiling point is under normal circumstances. So that's things that are at sea level, kind of like where we live. One thing I want you to remember is at sea level, the standard atmospheric pressure is going to be 1 atmosphere or 1 atm. Let's take a look at this vapor pressure curve, specifically for water. On the y-axis, you have vapor pressure measured in atm, and on the x-axis you have temperature measured in degrees Celsius. So this is a curve that shows vapor pressure for water. So we want to kind of interpret this curve and talk about the different parts of it. Right here at 1 atm and 100 degrees Celsius, that's when we have something that is going to boil because our atmospheric pressure is going to equal our vapor pressure. So let's take a look at this question. It says, what is the vapor pressure of water at 70 degrees Celsius? So you're going to take a look at this graph. You're going to look for 70 degrees Celsius approximately right over here. And you're going to take that across to the y-axis and you're going to say maybe approximately between 0.4 and 0.5 atm is the vapor pressure of water at 70 degrees Celsius. Another question is, what temperature would water have to be in order to achieve a vapor pressure of 0.75 atm? So you're going to take a look at our vapor pressure. Approximately 0.75 is here, and you're going to take that down to the x-axis, and that's going to be somewhere between here, which you could say could be 80 to 85 degrees Celsius. And that concludes our video today. Thank you for watching.